We're going to be starting Chapter 12 today. And with Chapter 12, what we're going to be looking at is the sum and difference. Sum means adding and difference means subtracting. So we're going to be adding and subtracting two angles and finding their sine and cosine after the subtraction or the addition. And so here's a little intro into this chapter. In this chapter, we'll be working with two different angles. And these angles often are our special angles, and the special angles are any multiples of 30 or 45, like 30, 60, 90, 120, 150, or any multiples of 45, like 45 or 135 or 225. Those are the two different angles that we're going to be working with. And what we have to do is we have to find the exact values. Now remember, exact values means no calculator, because probably we're going to have a radical in our answer and our calculator will not give us radical answers. So we're going to be finding exact values of the sine, the cosine, and a tangent of a third angle after we're given the two different angles in the beginning. And what we're going to be doing is finding the sine, cosine, tangent of their sum. So we have two different angles, maybe a 30-degree angle and a 45-degree angle. And 30 and 45 is 75 degrees. And we're going to be asked to find the exact value of maybe the sine of 45 or 75 degrees. Or maybe their difference. Maybe we'll have 30 minus 45 degrees, which is negative 15. Maybe we'll find the exact value of negative 15-degree angle. But what we're going to do is we're going to use formulas for the sum or difference. So we'll have a sum of two angles, or we'll have a difference of two angles, and we're going to figure out their sine, cosine, tangent based on some formulas. Now let me just give you some caution here, and please pay very close attention to this because a lot of people make these mistakes. When you have the sine of a plus b, it is so tempting to take this sine function and distribute it into the parentheses and call this the sine of a plus the sine of b. But this is not equal. The sine of a plus b is not equal to the sine of a plus the sine of b. You do not distribute trig functions, which is a sine, cosine, tangent, into parentheses. This is a really, really important concept, so please don't ever do that. Whenever you see the sine of a plus b, or maybe the sine of a minus b, or the tangent of a plus b or minus b, what you're going to do is you're going to go to a reference sheet that'll always be given to you. And on this reference sheet, you're going to have formulas. And the formulas are for the sine, the cosine, and the tangent of a plus b. So whatever a is, maybe a is 30 degrees and b is 45 degrees. That's just an example. They can be any two numbers. But how you figure out this sine of a plus b is you're going to find the sine of a, multiply it by the cosine of b, and then add to that the cosine of a times the sine of b. So this is expanded out the sum of two angles. The cosine sum is similar, but things get a little bit mixed up. It's the cosine of a times the cosine of b minus sine of a sine of b. And here's a tangent of a plus b. Get a little star here, which is indicated as a note down here. Sometimes, if you already know the sine of a plus b and the cosine of a plus b, you can always get the tangent of a plus b by dividing sine over cosine, because sine over cosine is equal to tangent. So that's all. If you already know these two values, you don't have to use this formula if you don't want to, but you can. Okay, and here are formulas for the difference, meaning the subtracting of two different angles. So if you have two angles subtracted and you're trying to find the sine, cosine, or tangent, you use these formulas over here. Now these a and b values, they can be any number, any letter. And down here I'm just showing you that it doesn't have to be an a and a b. It can be an x and a y, or it can be an r and an s, or a j and a k. No matter what, if you have the sine of two angles added together, it's not the sine of x plus the sine of y because we don't distribute. What we do is we go up to our formulas that are given to us, and anytime you see an a, you replace it with an x. Anytime you see a b up here, you replace it with a y. So the sine of x plus y is the same thing as the sine of x times the cosine of y plus the cosine of x times the sine of y. Because we've used this formula up here, we're just pretending that the a value is x and the b value is y. So we're just looking up here and replacing them. And in the second example, instead of having letters, we have actual numbers. Well, maybe we want to find the sine of 300 degrees, and we're not sure what that is, but we do know the sine of 270 and the sine of 30 and the cosine of 270 and the cosine of 30. So what we're going to do is we're going to split 300 up into 270 plus 30. So let's just split up because they're equal to each other. So the 270 is the a and the 30 is the b, and I go up to this formula here for the sine of a plus b, and I replace the a with a 270, so that is the sine of 270 times the cosine of 30, and these are all degrees. And then you have to add to that the cosine of 270 degrees times the sine of 30 degrees. And because these are values that we know, we can just substitute them in. Remember the sine of 270, you can get that out of your calculator if you want, or you can set up a unit circle and go down to 270, and the x and y, 0, -1, you know the x is cosine and the y is sine. So however you want to get this, the sine of 270 degrees is equal to -1. The cosine of 30 degrees, that's one of our special things from the blue sheet that we should know. The cosine of 30 is the square root of 3 over 2. And we're going to add to that the cosine of 270, well, that's just 0. And the sine of 30 is a half. So we have -1 times the square root of 3 over 2, which is negative square root of 3 over 2, and 0 times anything is 0. So the answer, the final answer, the sine of 300 is negative square root of 3 over 2. So we've found the sine of 300 by splitting it up and using the formulas up here. Another way we could have gotten the sine of 300 degrees is we could have gotten a reference angle, right? This is quadrant 4. The reference angle is 60 degrees, and the sine of 60 is the square root of 3 over 2, and in quadrant 4, sine goes negative. So we could have found this in a couple chapters ago by using reference angles, but this is just another method to get the same answer. Now what we're going to do, this one is a lot trickier because it contains radian measure. -2 pi over 3. Well, what we did here, or what I did here, is I split it up. And I know -2 pi over 3 is the same thing as pi over 3 minus pi. Well, pi is the same thing as 3 pi over 3. So 1 pi over 3 minus 3 pi over 3 is -2 pi over 3. So I'm just splitting this up so I can figure out what the cosine of 2 pi over 3 is. So I'm going to go up to the cosine of the difference because this is a subtraction. So I'm going to go over to this formula right here, the cosine of a minus b, and the a value is going to be pi over 3 and the b value is going to be pi, and I just use this formula right here, and that says we're going to write down the cosine of a, which is pi over 3, times the cosine of b, which is pi, not negative pi, but just plain pi. And then we're going to add to that the sine of a, which is pi over 3, times the sine of b, which is pi. So that's using this formula, and we filled in the a and the b value. Well, cosine, well, we don't really like pi's or, radian measures. So what we can do is we can just convert pi over 3 to 60 degrees. And we can convert pi to 180 degrees. If we'd rather use degrees, that's always fine. This is the sine of 60 degrees times the sine of 180 degrees. So that's just converting to degrees, just to make it more familiar to us. Well, the cosine of 60 degrees, this is a blue sheet question, that is 1/2. The cosine of 180 degrees, that's -1. The sine of 60 degrees is the square root of 3 over 2. And the sine of 180 degrees, well, that is equal to 0. So what we have is 1/2 times -1, which is -1/2, plus anything times 0 is 0. So our final answer is -1/2. So there's our answer. And we could have gotten this by calling this -120 degrees and finding the cosine of -120 with a reference angle of 60 and knowing that's quadrant 3, so cosine goes negative. There are many ways to get this answer. And actually, because this has no radical in the answer, we could have asked our calculator to figure that out for us. But that doesn't always happen. A lot of times we'll have radicals like this one. Now what we're going to do is we're going to use these same formulas in just a few different ways. We want to find the exact value of the sine of 15 and the cosine of 15 and the tangent of 15 by using the formulas on the previous page. So what you're probably going to do is you want to flip back and forth or just watch me and you can see the formulas that I'll use. Well, 15 is split up. 60 minus 45 is equal to 15, so I've just split this up. 15 is equal to this. 15 is equal to a lot of things. I could have put 45 minus 30 if I wanted to. There are different ways to get 15, but I just chose 60 minus 45. So now here's A, here's B, and this is the sine of the difference of two angles. So we're going to be using this formula here, the sine of A minus B, sine A cosine B. So that is sine 60 cosine 45 minus cosine A sine B. So cosine 60 sine 45. So there's our setup using our formulas. Well, the sine of 60 degrees, that's a blue sheet question. That is the square root of 3 over 2. The cosine is a blue sheet question. That's the square root of 2 over 2. The cosine of 60 degrees is 1/2. And the sine of 45 degrees is the square root of 2 over 2. So those are the exact values that you can get off from the chart or 30, 60, 90, 45, 45, 90 triangle. However you get these need to be known. Okay, now we need to know how to multiply two fractions. Well, you multiply two fractions by multiplying the numerators and multiplying the denominators. Square root of 3 times square root of 2 is the square root of 6. 2 times 2 is 4. 1 times the square root of 2 is the square root of 2. 2 times 2 is 4. And now we have like denominators, or we always did, but we can subtract those because they have common denominators. So this final answer is the square root of 6 minus the square root of 2 all over 4. And you cannot combine those two radicals because the radicands are not equal. So there's the sine of 15 degrees. And we can always check this on our calculator, but our calculator will give us a decimal value. Make sure your calculator is in degrees mode. And if you want to know the sine of 15 degrees, it'll be that long decimal because our calculator would never give us this radical answer. But I'll show you that this decimal is equal to that radical that we just got by alpha, the square root of 6, minus the square root of 2, and you should be following along on your calculator just to prove it to yourself, all over 4. So these two answers are exactly the same as the sine of 15 is a decimal and this radical 6 minus radical 2 over 4 as a decimal. They're the same thing. So we've just shown that we've done this correctly. The next one is the cosine of 15 degrees. Well, A is 60 again, and B is 45 again, but we have a cosine of the difference of two angles. So we're going to use the second one, cosine A, cosine B, plus sine A, sine B. So that goes the cosine of 60 times the cosine of 45 plus the sine of 60 times the sine of 45 degrees. So we're going to use the same values that we used up here. The cosine of 60 is a half. This cosine of 45 is the square root of 2 over 2. The sine of 60 degrees is the square root of 3 over 2. And the sine of 45 is the square root of 2 over 2. And again, all we have to do is 1 times the square root of 2 is the square root of 2. 2 times 2 is 4. Square root of 3 times the square root of 2 is the square root of 6. 2 times 2 is 4. So our final answer is the square root of 2 plus the square root of 6 all over 4. It's not exactly the same as above, but the numbers pretty much are the same. We just have an addition here instead of a subtraction. So let's see if that is actually equal to the cosine of 15 in our calculator. So we got cosine of 15, which is that long decimal. And now we're going to see if the square root of 2 plus the square root of 6, the square root of 2 plus the square root of 6 all over 4. And is that the same thing as the cosine of 15? Yes, they're exactly the same. So we did our math right. The next thing we're going to do is the tangent of 15 degrees. So we have a choice. We can either use the tangent formula right here, the tangent of A minus B formula, or if we want to, we can do the sine of 15 divided by the cosine of 15. Well, let's just use our tangent formula since we haven't used tangent yet. So the tangent of the difference of two angles is the tangent of A minus the tangent of B. So we have the tangent of 60 minus the tangent of 45, all divided by 1 plus the tangent of A times the tangent of B. 1 plus the tangent of 60 times the tangent of 45. The tangent of 60 is the square root of 3. The tangent of 45 is 1. And in the denominator we have 1 plus the tangent of 60 is the square root of 3 times the tangent of 45, which is 1. So what we have is the square root of 3 minus 1 over 1 plus the square root of 3. Well, I truly wouldn't mind if you left it that way, but we're supposed to rationalize the denominator, so we have to multiply the top and bottom by the conjugate of the denominator, which is 1 minus the square root of 3. Remember the conjugate of the denominator. So we have to FOIL the top. Square root of 3 times 1 is the square root of 3. Square root of 3 times negative square root of 3 is negative 3. Negative 1 times 1 is negative 1. And negative times negative is positive square root of 3. And in the denominator, all we have to do is F and L. 1 times 1 is 1. Positive times negative is negative. Square root of 3 times square root of 3 is 3. And so now all we have to do is combine like terms up here. Square root of 3 plus the square root of 3 is 2 square root of 3. Negative 3 minus 1 is negative 4. And 1 minus 3 is negative 2. And now what we can do is we can split this up into two different parts. We have 2 square root of 3 over negative 2. And then we have a minus 4 over negative 2. The 2's will cancel. 4 over minus a minus is plus a plus. Minus a negative is plus. And so what we have is the square root of 3 over negative 1. And I'm running out of room, which is negative square root of 3. And then 4 over 2 is 2. So negative square root of 3 plus 2 would be our final answer for the tangent of 15 degrees. This is a little bit blurry. Let's see if I can focus it up a little bit. There you go. Right, so there was a lot of work involved in that. And let's see if we can get the tangent of 15. See if we're right. And what did we call it? Negative square root of 3 plus 2. Well, look at that. We are right. Very good. Now what we're going to do is find the sine, cosine, and tangent of 165 degrees by using the formulas. So we'll go through this a little more quickly because we know, or we can just look at these formulas: sine A, cosine B, sine 30, cosine 135, plus cosine A, sine 135. Now the sine of 30 is a half. The cosine of 135 degrees, well, that's in quadrant 2. Quadrant 2, 135 has a reference angle of 180 minus 135, which is 45 degrees is the reference angle. So what we're doing is finding the cosine of 45 degrees, but in quadrant 2 it is negative. All students take chemistry. So the cosine of 135 is negative square root of 2 over 2, negative cosine 45. The cosine of 30 is the square root of 3 over 2, and the sine of the 45 degree reference angle, in quadrant 2 it is positive, square root of 2 over 2. So what this gives us is negative times positive is negative square root of 2 over 4. Square root of 3 times square root of 2 is square root of 6 over 4. So we have, as a one fraction, negative square root of 2 plus 6 all over 4. And that's the final answer there. Let's see if we're right. Sine of 165 is that, and negative square root of 2 plus, square root of 6, sorry. The square root of 6 all over 4 is the same exact value. So we've got that checked. Square root of 2, negative square root of 2 plus the square root of 6 all over 4. Cosine A plus B is the cosine of A times the cosine of B minus the sine of A times the sine of B, says the formula back here for the sum, for the cosine of the sum of two angles. Cosine of 30 is the square root of 3 over 2. Cosine of 135, we just did it up here, it is negative square root of 2 over 2. The sine of 30 is a half, and the sine of 135, we just did it up here, is the square root of 2 over 2, and it's positive. So we'll put these together. Square root of 3 times square root of 2 negative is negative square root of 6 over 4, minus 1/2 times the square root of 2 over 2 is the square root of 2 over 4. And when you put those together, both of those are negative, so negative square root of 6 minus square root of 2 all over 4 is our final answer. And let's see, what is the cosine of 165? Negative that number, which is, I'm just going to pop up here so I save myself some time. Subtract those, and you get the same exact answer. So there's our check. And then one last time, the tangent of the sum of two angles is the tangent of A. Oh, you know what? Oh, let's use the formula. Tangent of A, tangent of 30, plus the tangent of B, all over 1 minus tangent of A times the tangent of B. Tangent of 30 is the square root of 3 over 3. Tangent of 135, well, the tangent of 45 is 1, and in quadrant 2, tangent goes negative, so it's a negative 1. 1 minus square root of 3 over 3 times negative 1. So there's our replacements. So what we have is the square root of 3 over 3 minus 1 on the top, and then 1 minus a negative is plus the square root of 3 over 3. This is a complex fraction, so we can just multiply every single term by the denominator, the common denominator, which is 3. So I'm going to multiply this by 3, this by 3, this by 3, all 4 terms by 3. And that just cancels out that denominator, and it becomes the square root of 3 times 1 minus 1 times 3 is 3. And in the denominator, 1 times 3 is 3, and those cancel out, and we get plus the square root of 3. And we really should rationalize the denominator by multiplying the top and bottom by 3 minus the square root of 3. And hopefully we can go really quickly here. 3 times the square root of 3 is 3 square root of 3 minus 3 minus 9 plus 3 square root of 3 is on the top, and on the bottom 3 times 3 is 9 minus 3, which is 6. So we've got a 6 on the bottom. 3 and 3 is 6 square root of 3. Negative 3 minus 9 is negative 12. And then we can reduce everything down by 6. So we have 1 square root of 3 minus 2 all over 1. So it looks like the square root of 3 minus 2 after we get done reducing that thing down. Let's see what the tangent of 165 is. And then let's see what the square root of 3 minus 2 is. Well, hallelujah, it checks out. So this is our final answer, the square root of 3 minus 2, and that's how you use the formulas. See you tomorrow.